What's up guys, Shawnthebro here, and today we're going to be going over interactables in our first-person shooter tutorial series, and this is part 4. This is going to be for specific objects that we can interact with. We've set up a lot of logic in the previous episodes to allow us to switch our weapons based on looking at them or just walking close enough to them, the priority between those two, and being able to look at a specific object in the scene, such as this test object. In this episode, we're going to be setting up a door that we can actually look at, press a button to interact with it, and be able to go through it. We will, of course, be able to close it as well, and when the door is shut, we will not be able to walk through it. So it has actual collision, and it functions as a real door. I want to give a huge shout out to my Patreon members and YouTube membership subscribers. Thank you guys for all the love and support. I really appreciate it, and I'm ready to get into this episode that you guys requested, so thank you so much for that. If you want to get caught up in the series before watching this episode, you can check out everything we've done, how we've created our enemies, switching weapons, aim down sights, and all those other topics. I'll leave the playlist right here in the top right corner. Alternatively, if you just care about the interaction system, I'll link you to the first part of that right here, so you can get caught up on everything you'll need to complete today's episode. As usual, we will start in the code today. And I want to go to the base interactable actor class that we have, specifically the header file. So if we're in base interactable actor.h, you can see it looks very familiar as it has the last few episodes, but I've added two new things this time. I've added a U function, use interactable. And this is essentially the logic that is going to occur when the character interacts with this object. So in the previous episode, we set up all the logic to be able to look at and trigger interaction with different objects in the scene. But the objects never actually did anything. We just knew that we had interacted with them. So use interactable is what's going to happen when the object has been interacted with. In the case of our door, it's just going to rotate open, perhaps change the collision depending on what type of door you have, and things like that. You could also have a lever, which would play an animation on the lever, or just pull it a given direction. And of course, you could really do this with anything. You could have any object you can interact with in the scene. So essentially, I have a function that is a U function of blueprint implementable event, meaning that we can call it in the code, but we are going to fill out the logic for it in the blueprint. And we're going to do that in a child of the base interactable actor class, which will be our interactable BPs. I gave it a category of interactable, but this isn't required. This is just so it's easier to find when you're searching for it. Or if you're scrolling through the list of functions in the blueprint, it will be a little bit more organized by these categories. And I just called it void use interactable. I've also added a boolean called is already being interacted with. This is important because some of your objects, you might be able to interact with them and cancel them out. But in the case of the door, I wanted the door to open fully before shutting it, like this. I didn't want to be able to spam the button and start shutting it or try opening it again while it's already being opened. So no matter how many times I press it, if it's already being interacted with, it will wait until it is complete before we can interact with it again. If you don't care about that, you can skip this boolean, but I would recommend at least having it because you don't have to utilize it for each interactable object. And if there's some that you do want to utilize it with, then you can only put it on those ones. So it's up to you how you handle this, but I would recommend at least having something like this so that different interactables have the option. Now, as usual, we will go into our base interactable actor.cpp, and we'll go to the constructor. In the last episode, we had only defaulted the object name to object, but now we want to default our boolean as well. So is already being interacted with should be false by default because it hasn't been interacted with yet. Once you do this, we can go to our FPS tutorial character.cpp, and we want to scroll down to our interaction function. Because in our interact function, we had only accounted for if the item we were interacting with was a weapon. So here's my interact function, and we were checking to make sure that there was an actor that we could interact with, and then we were checking to see if it casted to a weapon. If it did, we were able to do all of our weapon logic. We may be able to interact with dozens, hundreds, thousands of things, in our game, and thus we want to make sure that each object can be accounted for. So after the if statement, I've added an else if statement. So if it doesn't cast to a base weapon type, we know it's not a weapon. So instead, I'm going to try and cast it to my base interactable actor class. And if that succeeds, we'll do a different logic separate from the weapon. Essentially, make a pointer called interactable actor and see if our interact actor, that is the variable on our character that just stores what we are actually going to interact with. So you see I have interact actor here. This is just the actor that will be interacted with upon pressing the interact button. So if we don't have anything to interact with, interact actor will be null. But if we do, that is exactly what we want to cast to this other type to see if it is one of these objects. So if interact actor can cast to this type, then interactable actor will be set, in which case this else if statement will be taken. And then inside of here, we just want to make sure that the interactable actor is not already being interacted with. So if not, is already being interacted with. If it's not, then we know that we should use the interactable actor. This is the first time it's being interacted with, or it's already been interacted with and is ready to be interacted with again. So we just call interactable actor use interactable. At this point, we're done in the code. We need to go into the blueprint of that actor. To this point in the series, I've only created the base interactable BP right here, and that was our cube that we created that we called test object 1. You can make a child instance of this by right-clicking on base interactable actor BP and create child blueprint class, which will automatically create a child of it. Or you could go to add blueprint class, and then in your all classes section, search for base interactable BP and make a child of this here. No matter how you do it, you'll get a blueprint class that you can rename, and I called it door BP. I'm going to call it whatever it is that the interactable is. It's that simple. You could create a code class for every interactable if you want, and then make a child of that, just like we did for base interactable BP. I honestly don't feel that is necessary because the interactables themselves will probably have very little logic overall, but it is up to you. Regardless of how you do it, once you create your blueprint class here, you can go into that class. And for me, I'm setting up a door. So if you want to follow along, you can do exactly what I do. But if you have a different interactable in mind, basically just make sure that you have some sort of mesh or something to visualize this actor. In the case of the door, I've made sure that I have 2 static meshes. So I just added a component and found the static mesh and added 2 of them. I added one that was the frame, and then a child of that, which was the actual door. Now, if you're like me and you don't have a ton of assets, then Unreal actually has some stuff for a door in the starter content. I happen to keep the starter content when I created my project, so it'll be in this folder. If you don't have this folder, you can right-click, add feature or content pack, and then if you go to content, you'll see starter content, and you can click add to project. This will give you a large variety of materials and meshes that you can use. It's especially helpful for people like myself who don't have a lot of assets to use. Going back to the blueprint, we have our static mesh here, and all I've done is selected the static mesh to be SM door frame. SM stands for static mesh, so static mesh underscore door frame. That is my parent mesh here. You'll notice I haven't changed anything else about it other than the mesh, the material on it, which automatically should put the material frame on, but if it doesn't, of course, you can just put any material on here or search for material frame. And I've changed the scale to be 1.5 because I did want this to be a little bit wider so the character could actually fit through it because we were going to put collision on it. My character was a little too big to fit through the standard 1.0 scale. It's kind of a thin door, so I made it 1.5, but that can also be dependent on your character model. Then, while I had static mesh selected, I clicked add and then static mesh again. which allowed me to make another static mesh that I renamed, right-click rename, to door mesh. That way I know exactly what this is. The door mesh is the actual door that we're going to rotate. In here, you can see I positioned it exactly in the door frame because when you get it, it starts out as all zeros, and that is not where I want it to be. That is in the center of the door, which is great, but I want it to actually line up with the frame. So for me, I put about 46 units over. That is just an arbitrary value that I found because it looked the best, but you can change it however you want. Just make sure that it resembles a door in one way or another. For the mesh, I put static mesh door, which again is part of starter content. And it will come with the material door and material class, but if it doesn't, again, just set your materials in here. These are all things of starter content, nothing I created. And nothing else needs to be changed. You can look at all my logic if you want, but you really don't need anything in particular. Now, as for the collision settings, the static mesh by default actually doesn't have a collision, so even though your collision will say block all dynamic for both the static mesh of the frame and of the door doesn't have any sort of collision. So if you want to add collision to an object when it's just a mesh, it's super easy to do actually. So if we go to our door mesh, for example, you can double click on the actual picture of the mesh, or you can go to the object in the content browser by pressing that little folder, browse the SM door in content browser, and just double click it here. No matter how you do it, you will get to the door in this view. So this is basically just the mesh and how it exists in the world. This is what it looks like. If you go to collision up at the top, you can add box simplified collision, and that will put a box around it. I already have collision, but let's say I remove it. When I select box simplified collision here, it will draw a little box outline. And so that is the collision of my door. You can do the same thing for the frame if you want, but it's really not required. Just as long as the door has it, we will be able to demonstrate what we're trying to demonstrate. We can now walk through this door when it's open, but otherwise the door will be shut. You can test this now, even though you won't be able to open your door. You should have collision and your character shouldn't be able to walk through it. Now, once you have all that done, go back into your door BP, and we're going to go into the event graph. We just have to set up the logic for what's going to happen when we interact with this object. You don't need any other events in here, so the begin play, the tick, they can be removed. Any other events in here can be removed. The only one we need right now is the blueprint implementable event that we created in the code, which is our event use interactable. So you can simply search for event use interactable and it will come up here. Once you do that, you have to remember that this use interactable is going to work for the door BP and any children of the door BP, but any other interactables can be entirely unique. So we want to make this logic specific to the door. We don't have to go grand scale or trying to make it generic enough so that all objects can use it. We just care about doors in this case, and you can even have multiple doors. So all we want to do is this door, we're going to open it, and if it's already open, we're going to shut it. It's that simple. What I decided to do because of that is just make a boolean is open. So I made a new variable of boolean type, and I called it is open. I then take that variable, get it, and drag it into a branch. Now, by default, is open is going to be false, and that is true. This door is not open by default. If it's false, we're going to have to open it. So if it's false, what I've done is I've created a timeline. And a timeline is a good way to handle things like doors and levers because A, it can actually rotate and move our object if we use it with something like set relative rotation. But B, timelines are actually able to be replicated very easily and very well. So this will work in something like a multiplayer scenario as well. To create a timeline, if you're not familiar, right-click in the graph and type add timeline, and this will pop up. Now, when you do it, it'll make a node like this, and you can name the timeline right here. I already have open door, but you can create whatever one you want. I'll create a new one with you so that you can see the process. So let's say open door live, okay, because we're doing it live. Now, once you have this timeline, you're going to double click on it, And you'll get this here, which looks confusing because it's just basically nothing. It added this one little row here. We want to add a track to it, and we're going to add a float track. So this is going to get us a graph. And what a timeline is it's a graph that literally just tracks value over a given period of time. In the case of a float track, we're just going to have two axes, two values. So we're going to have time and a value. We want to give this name whatever it is that you understand to represent the value of this. So this could be open ratio, open value. It's basically how much of the graph has completed, how much time has gone by. So essentially this track is just representing how long it takes to open the door. I typically just call it something like open door track. So in my case, I'll call it open door live track. I just call it the timeline and track. It's pretty generic, but it's up to you what you want to name it, so it doesn't really matter. Now, the length of the timeline is how long the maximum time for this timeline will be. So really what you want it to do is just be the amount of time that you expect it to take for this door to fully open. If I want my door to open in 1 second, I set the length to be 1.0. You can see when I did that, the gray area of the timeline only goes to half the screen because it goes to 1.0 now. Everything beyond that is essentially ignored. Now you can scroll out and scroll in to this graph to get a better view of it. We're going to make 2 points. We're going to do it nice and simple. We're going to have the door from start opening to finish opening a linear relationship. It's always going to open at the same rate. So we're not going to like start opening it really fast, then it opens slow at the end. We're going to do something really simple. Just going to open at the same rate. So we're going to right click in the graph, add a key. And for this example, we can start at time 0. So once we trigger this timeline, that's time 0, and the value is 0. It is 0% open. You can think of this value as a ratio if you want. On a scale of 0 to 1, it is 0. So 0%. Now we're going to right click and make one more key here. And I'm going to go to the length of my timeline because I don't have to do anything special with this. So if my length is 1 second, then 1 second in, the value is going to be 1. 100%. The ratio is complete. The graph will be a linear relationship going from 0 at 0 seconds to 1 at 1 second. You don't have to make it more complicated than this for this case. This is just going to open a door from 0 to 1, or basically 0% to 100% in 1 second. It's okay if that doesn't make perfect sense just yet. We're going to use it, and so seeing it should help. Once you've done that, you can go back into the event graph, and I'm going to delete the one that we just made, and I'm going to use this other one that I already have. But if you want to take a look at that, it's the same thing as I just created. I have this called open door track, which is a float track, and I have my first key at 0, 0, and my second key at 1, 1. Now, if the door is not open and we're interacting with it, we're going to be opening it. So if is open is false, we're going to go into play from start. You could just put it into play. Play from start, make sure that we will always play from the start of this timeline, which allows us to open the door over and over again. So if it's closed, then we can open it. We don't have to reset the timeline or try and go backward or anything silly like that. Now, the timeline will work every single frame. Whenever this value updates, the update path is taken. So since we don't want the door to just skip from completely shut to completely open, we want to update it on each update of the timeline. And to do this, it's actually very simple. We basically just want to rotate the door. We have our door mesh. Remember, we don't want to rotate the frame as well, just the door mesh. So we can drag our door mesh into the scene here. Drag off of the door mesh and type set relative rotation. And then we only want to rotate the door one way. The door doesn't rotate up. It doesn't rotate toward the camera. Nothing like that. We just want to rotate it like it's on hinges, like a real door. So we don't need a bunch of additional logic here. We just need one axis to rotate it on. So I right click on my rotator and hit break struct pin, split struct pin. In our case, the new rotation Z, the yaw, is the one we want. But if for any reason you pick the wrong one, you can just change it to a different one. It's not really a big deal. You'll see that it's rotating and that it doesn't look right, so you can just change it. But basically, the X and the Y don't need to change, only the Z needs to change. Now, the timeline will actually give you the value of the track. So remember when we set up the key node value here? This value is what's being returned by the timeline. So you can take the current value of the timeline and pass it into a lerp, which then gets passed into the rotation, and then we'll get the current rotation of the door at this point in time. What lerp does is it goes from A to B at the given rate. A door typically opens 90 degrees in one direction. So if we go from 0 degrees, which is the default rotation of the door, to 90 degrees at the rate of the timeline, we will go from 0 degrees to 90 degrees in 1 second. So take your open door track and get ready to put that into a lerp function. So float lerp, pass the open door track into the alpha, change your B to be 90 degrees, or 90, and then take the return value and put that into your set relative rotation Z value here. Once you do that, your door will be able to rotate when you interact with it. But there are a few other things we should do. Again, we don't want to keep interacting with the door and keep restarting the animation, and we also don't want to like open it twice as fast. So once we have interacted with it, I set the door to be already being interacted with. Remember this boolean that we made earlier in the code? You can just set is already being interacted with. Make sure you check that. It is true. Now, the timeline also has a finished, which is when the timeline completes and the final key is reached on the track. So 1 second has passed and the value of 1.0 has been reached. Additionally, the length of the entire timeline has completed at this point because it's also only 1 second long. The finished event will be called here. Because of that, we can say that the door is now open. Okay, we don't want to necessarily say it's open as soon as we press it, because sure, it's opening, but it's not fully open. So once it's finished, we can set our isOpen boolean to be true, and then we can say this object can be interacted with again. So we're going to disable is already being interacted with, set it back to false. Now, at this point, we're actually done with opening our door. The only thing we need to be able to do is close the door. And actually, it's essentially the exact same function. There are a few things we have to change here, but really, it's pretty much exactly the same. So let's go back to event use interactable. If it's open already, this is true now, we want to be able to close the door. To do that, I made a new timeline, although you could technically use the old timeline. If you are comfortable with timelines, go for it. But making a new timeline is fine anyway, because you may want to have some differences in opening and closing a door. They could do different things. They don't have to. So I made a new one that I called close door. And close door is essentially the same timeline but backward. It is a float track with a length of 1. But at time 0, I have value of 1. Essentially, it's fully open at 0 seconds. Since we're closing it, when 1 second has passed, the value should be 0. 0 would be fully shut. So if you add your two keys and just reverse what we had on the open door, you'll get a line that looks like this. It's a linear relationship, but it's going down. If we do that, then we can, on update, do the same exact logic. We can use our door mesh, call set relative rotation, split the rotator pin, and take the close door track value, pass that into the alpha on a lerp function of 0 to 90, and use that return value into the Z rotation, or the yaw, on the door. At this point, the object is being interacted with because the door is on its way to closing. So we don't want the user input to interrupt that or block that in any way. Once the close door timeline has completed and the door is fully shut, we want to make sure isOpen is set to false now. Remember, isOpen was true, that's why we're closing it, so now we're setting it to false. Then is already being interacted with should be set back to false as well because the interaction has completed. And there we go, guys. With all that out of the way, we can fully open and shut our door. So if you come into your game, I can walk up to my door. I won't be able to walk through it. I can press E to interact with door and walk through it. One additional note I should have mentioned, if you go to your door BP and go to your class defaults, make sure that you set your object name to whatever it is that you want to call it. By default, it is object. So if I come into here, it will say press E to interact with object. However, I want it to be more specific, so I'm going to say door, and changing that in here will allow us to say press E to interact with door. Then we know that we can interact with it. And that's how you can set up a door in your first-person shooter tutorial series. So I hope this video helped you guys create a door in your game, and if it did, please subscribe. It does more for myself in the series than pretty much anything else you can do, and it's free. If you do want to give me some support, you can check out the Patreon and YouTube membership like all these kind souls have. Thank you guys for everything that you've done. I'm really incredibly grateful for you guys, and I'm so happy that you are enjoying the series. If you need any assistance with this episode or things aren't working the way you'd like them to, feel free to reach out to me in the Discord community. It is completely free, and I'd be happy to help you with any of the problems that you ran into. Anyway, guys, like I said, that's all I got, so thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.